Okay, we will be learning what is the least square method um, for the representation of the regression. This is the continued part. The previous video, if you haven't watched till now, you can watch. It's already available. So the least square method is a mathematical approach which is uh, data fitting regression analysis on the predictive model that is helpful to find the best fit line and the curve that minimizes the sum of the squares of the differences between the observed point and the predicted values. This technique is widely used in the statistics and machine learning for the engineering. So, this is the equation of this given line. Here, if you can see, this is the regression line, and you need to, the definition says, you need to uh, though it helps to find the best fit line or the curve that minimizes the sum of the squares, the differences between the observed point and the predicted values. Suppose these are the predicted. Uh, okay, we're taking the squares of this value to find the thing. The least square method is widely used to generalize the equation of the two variables, and um, when the values of the dependent and the independent variable, they are represented as x and y coordinate in the 2D Cartesian coordinate. Initially, they are known as the mark on the plot. The plot obtained at this point is called the scatter point. This is nothing but we call, according to our definition, is called the scatter point. And moving forward, then we will try to represent all the mark points as the straight line or the linear equation. We will try to represent all the marked points as the straight line or the linear equation. The equation of such line is obtained with the help of the least square method. Least square method. This is done to get the values of the dependent variable for an independent variable which the value was initially unknown. This helps us to make the predictions for the value of a dependent variable. Why do we use the least square thing? Here it is described. So this is A and this is B, the individual. So in the statistics, um, when the data can be represented on the Cartesian plane by using the dependent and the independent variables as x and y coordinates, it is the scatter data. You can see the scattered data in the image. There are many scattered data points, data coordinates. Okay, this data might not be useful in making the interpretations and the prediction the values of the dependent variables for the independent variables. So we try to get an equation of the line that fits best for the given data points with the help of the least square method. The least square method finds the best fit lines for the set of the data points for a simple linear regression, which is a line of the form y equal to mx plus c. or y is the dependent variable and x is the independent variable. A is the slope of the line, uh, and b is the y-intercept. It is of the form like this, and the equation is y equal to x a plus sorry ax plus b ax plus b, where the y is the dependent variable, x is the independent variable, a is the y-intercept, and b is the sorry b is the y-intercept, and m here is represented by a, the slope. So the equations for the slope of the formula as given here. I already described those things. So this is given. Slope is nothing but let's remove this one. This part is not required for now. This will confuse you. So in the previous video you have already watched the things. Wait, I am describing. It is not wrong. I haven't described it, that's why I cut this one. So let's move to the notes and we will understand the things more further way. So best fit line using the least square method. Suppose you think of the data having the equation like this, and that is the scattered points. We suppose drawn a best fit line that passes through the maximum of the data, and we drawn it like this. Wait, I'm doing some more points so that it passes and the image will be more clarified to you. Suppose a line passes through this. Okay, you can now see the maximum of the data passes through that point. So what you will know here is the least square method. Suppose you have the data points here. You have the data points, that is xy. X is the independent variable, y is dependent on x. 5, 6, 7 continues, up to xn, not writing that one. So removing it and writing to xn. So let's say to yn. Let the equation of the line is y equal to ax plus b. The previous equation in the previous video is the best fit line. The equation satisfies y equal to ax1 plus b y2 equal to ax2 plus b y3 equal to ax3 plus b like that. So yn equal to axn plus b. Here mm, this y1 and x1, all this value, this will satisfy the equal value when the line passes through the best fit line. This value that we are getting from the equation, that is approximated value, is this line we taken an approximation of all the value that covering maximum of the points y equal to ax plus b. But there must be some error because we have taken all the data points like this, like this, like this, like this. There are some and there will be some error in those points. So we will find the error from those data points too to get the precise value. So what we will do here is when y1 and this y1 are not same, this case is okay when the y1 falls on the particular line like these data points, like this, like this, like this, like this. But for the data ones that y1 is not same as capital Y1 like this, the fix we write it as y1, sorry, we write it as error value, which is nothing but y1 minus small y1 equal to small e1, the small error. y2 minus small y2 equal to e2, a small error. y3 minus y3 equal to small error e3. This continues up to yn minus yn equal to en. These are when y and capital Y1 and Y1 are not same. Okay, so what we will do is we will square all this value, all this value to get a residual sum of the squares. So now we will do the thing is E equal to E1 square plus E2 square plus E3 square plus E4 square up to En square. This is the residual sum of squares. This is the residual sum of squares. We take minimum of E, minimum of E. So the errors sum of I equal to I to n. We are writing this, okay. A x I. So if you are not getting the thing, look here. Look here. I'm just putting the values, putting these values. X I, writing it in the terms of I. So I plus B minus yi minus yi up to, I'm taking the squares. The representation of the less residual sum of square is this: axi plus b. This term is, if I write, this term is yi minus small yi. So this is the equation you are required of. So now what you will do is, now what you will do is we need the minimum value, the minimum. How did we get those things? We partially differentiate with respect to a, as these variables are dependent on two things, a and b. we will partially differentiate with the two things A and B and equalizes its value as 0. So y b equal to sum of axi plus b minus yi, where the square of this thing will be the coefficient uh, of that thing. As you can remember what we are doing in the differentiation. So the coefficient is 2. This is from I equal to 1 to n. This is equal to 0. So the sum of I equal to 1 to n axi plus b equal to I equal to 1 to n yi. This will be nothing but the normal equation. The normal equation will be a, that is constant, taken out xi plus sum of b. B is also constant and the sum of the thing will be n. So this will be sum up to n. So this value will be n, totally n, equal to sum of yi. This is the equation. This is the normal equation. Got it? The another normal equation we will find when we differentiate with respect to a. So we are now differentiating it with respect to a also. So the constant taken out. So 2 sum of I equal to 1 to n axi plus b minus yi equal to 0. What we will do here is we will multiply xi both the sides. So 2 is vanished already. So when we multiply xi, the equation becomes a xi square plus b xi equal to sum of yi and xi. 1 to n. So the normal equation is a sum of xi square plus b sum of xi equal to sum of xi yi. Equation 2. It is the normal equation. Okay. Getting the things. But mistakenly, I have told you something wrong here. We have not multiplied xi's here. When we do the differentiation thing, we will get xi here. Okay. When we do the first, I am explaining this whole scenario again. So look here, the square become the coefficient. Now deep diving into the inside part, here the thing this and this is constant. Their adjectives, b is only the variable. But in this case, if you are noticing, coefficient will be taken out. This is the coefficient, then the inside thing. Okay, these are the two normal equations you got. So you have a question here that considering regression lines, 543a, we're taking the same data as of the previous video. Yes, the previous video. I'm just doing the copy paste. Wait a minute here. This is the question, and here, if we are putting, we have the two normal equations. If you remember, we have two normal equations. Uh, this was creating H2. So we have two normal equations, that is a xi plus b into n equal to sum of yi and a xi square plus b xi psi y. So we have already all the values. So we will put the values. So what is the equation? 543a plus n is 8 equal to yi 557. Here also 36885 a plus xi is 543 b equal to sum of xi yi is 37835. You need to solve the two equations and find the value of a and b. Okay, you need to find the value of a and b. After finding the values, you need to after finding the values, you need to comment it down and moving forward. We will be learning the second degree parabola best fit curve equation. Okay, please comment. I will make video if you are not getting the things. So for second degree parabola best fit curve, x is suppose for I have coordinates x1, y1, x2, y2, x3, y3 up to xn, yn. So the equation are a plus bx plus cx square. The equation of the line, this is the equation. Your difference is this one. Okay, yi and xi. This is a difference. So the total error is sum of from I to n. What you will do is sum of yi squares is the previous one. So putting the value from axi, sorry, a is constant, a xi plus ci square, and the last is yi square. So differentiating all the value with respect to a, b, and c, we are getting the three normal equations we will be getting. We will solve it and find the value of a, b, and c. Then we will put those values and get the equation of the line. No, that is our final goal, the equation of the line. Here I will solve an example like this. You will be solving the previous example I have given, uh, and also I will give another one question, means two questions for you for the homework. You will solve and write the equation in the comment. So, by solving the three things, these three, we are getting NA plus B sum of xi plus C sum of xi square equal to sum of yi A sum of xi plus B sum of xi square plus C sum of xi cube equal to sum of xi yi. And for the third one, you have the coefficient xi square, xi cube, xi power 4, xi square, y. These are easy things. Can remember these things. These are your equation for normal lines. Now we have the question is, I'm saying it, writing the question below. You have the data. Experiment is given xi, yi. You need to find many things. You need to find given with xi and the yi values. You need to find the xi square, xi cube, xi power 4, xi yi, x square, y square, these things. 5 extra values you need to find. Then you will get the equation of the second degree parabola. So values are 0, 1, sorry, 1, 3, 2, 4. Small equations I am giving because there will be huge calculation. So you need to find xi square, I'm making some distance also, yi square, sorry, not yi square, you are not required, xi cube, xi power 4, xi yi, xi square, yi square. Okay, so 0, 0, 0, pause the video, try first, then check your answers. This is 1, this is 4, this is 9, this is 16, 1, 8, 9, 27, 4. Now squaring these values, 1, 16, 81, 56. Now multiplying these values 3, 8, 15, 24, and then squares with yi means these values 0, 3, 16, 45, 96. Now summing, you are getting 10 here, 19 here, 30 here, 100 here, 354, 50, 160. Now put in all those values in the equations you will get. Now putting all these values, the equations are: first one is Na plus uh, xib, this is your sum of xi, sum of yi, sum of xi square, sum of xi cube, sum of xi power 4, sum of xi yi, sum of xi square, yi square, then b plus xi cube is yi, sum of y is 19. Then chain a plus xi squared is 30b plus xi cube is 100c equal to xi yi. Sum is 50. Next is xi squared is 30. If xi cube is 100b, 354c, and this is 160. Getting the three equations: equation I, equation 2i, equation 3i. Now solving the three equations you will get the values is getting what I am writing. Sorry, this is no value, only a plus 7 mm, mm, b plus, no, this is minus 0.14. Sorry. 1.77 x plus no, minus 10 per discussion. This is the equation of second degree parabola. Okay, I think you're clear about the things of the least square method. You need to remember the three equations. These are very easy. You need to just multiply xi. If you remember one equation, you just need to multiply xi with the rest. Okay, you are not required of remembering this also. If you are that much knowledgeable, this is nothing but this thing. So we are doing the squares. So sum of that value will be n, and the next one will be sum of xi, and the next will be sum of xi square. The variables remain the variable. Got it, no? When you can see the previous two equations also, that these are nothing but y equal to ax plus b. Okay, I think you can do this question. This is your homework, and I think this video is enough for the thing, and you need to comment the answer. Okay, we have done till the second degree parabola. In the next video, we will complete the regression by doing the power curve. Okay, so let's close this video. So thank you.